Assalamualaikum and hi, my name is Muhammad Irfan and I'm from Group 8, presenting our project design for KM21603, Applied Thermodynamics, in which the project we design is a mini prototype solely for group assignment purposes to help us understand better of a steam heat engine mechanism. Next, I'm going to introduce my group members. Aside from me, their names are Raycole Dikson, Richie Engelbert, Syahmi bin Sabri, and also Rafiq Saadudin bin Jaudin. Firstly, our group designed a mini prototype of a steam heat engine. Moving on, I'll be talking about the description of the steam heat engine, including the objective and also the overview. Heat engines are devices that convert thermal energy into mechanical work. Meanwhile, steam engine, for instance, employs steam as the working fluid to generate power, while internal combustion engines utilize the combustion of fuel within a cylinder to produce mechanical work. The objective of this mini project is to design a simple heat engine using any household materials which is able to obey the second law of thermodynamics. The performance of this heat engine is determined by calculating the heat supplied, the work done, and also the efficiency of the heat engine. Moving on to the overview of our mini project design. First, we created a steam heat engine using household materials. We modified the vape tin as the boiler for high temperature tolerance and water containment. Next, we used a car toy components to build a sturdy framework. We positioned the vape tin in the center with a steel straw for a water entry. Then we apply heat to the tin with a portable flame torch, converting water into steam. Next, the steam traveled through the straw, generating pressure. We placed a plastic fan blade in front of the straw to capture steam pressure. The pressure made the fan blade spin, demonstrating the conversion of thermal energy to mechanical work. This emphasized simplicity and common materials to illustrate heat engine principles and the transformation of heat energy into work. That is all from me. I pass the presentation to our next presenter. Thank you.
Assalamualaikum and hi, my name is Mohd Rafiq and I will present about the problem statement and the scope of this project. This project explores energy transformation and entropy in simple heat engine prototype using household materials. It aims to demonstrate the conversion of heat energy into mechanical work, following the second law of thermodynamics. The project provides practical experience in engineering and thermodynamics, enhancing our understanding of energy transfer and conversion laws. Scope of this project is to design and construct a simple heat engine using household materials, ensuring adherence to the principles of second law of thermodynamics. Identify suitable materials for the engine's functioning and develop mechanisms for steam generation and steam channeling into a fan. Assess limitation and potential risks associated with the prototype. Thank you.
Hi, my name is Raycole Dikson, and today I will present about the procedure of obtaining the data. First of all, we set up the prototype and then we prepare the necessary tools such as flame gun and also water itself. And then we measure the mass of the water. And then we start the experiment by burning the prototype using our flame gun. And then we measure the change in the temperature. And after that, we measure the time for the prototype to heat up. And then we calculate the work done, calculate the heat supply, calculate the heat loss, and calculate the efficiency. All the calculation will be provided on the next slide. As you can see on the picture, this is the overall overview of the prototype. On the left, you can see that there are some sort of fan that we use as a propeller. And to attach with the body of the prototype, we use some wire. And then the main body itself is made out of a thin aluminum that has a lid that can be open and closed, where we drill a hole into it so that the steam can go out of the hole. And to attach it with the tire, we actually use some screw that we use glue it to the tire, and the tire itself is actually a part of this assembled toy car. This part of the slide will be the demonstration video. As you can see on the video, the first thing that we need to do is using the flame gun to heat up the tin so that the water inside of it will turn into steam, and then the steam will exit to the hole that has been drilled, and it will produce some sort of wind that then will turn the propeller, at the same time pushing the prototype into the opposite direction, which is forward. This process will take some several time as it will take time for the heat to make the water turn into steam. I will now proceed to the calculation part of the presentation. The first calculation is heat supply. Heat supply is equals to, in bracket, mass of water times specific heat capacity of water times change in temperature, and plus with mass of water times latent heat of vaporization. Based on our measurement, the mass of water is equal to 0.15 kilogram, and then the specific heat capacity of water is actually equals to 4.18 kilojoule per kilogram degree Celsius. The change in temperature is equal to 75 degrees Celsius, and the latent heat of vaporization of water is equal to 2260 kilojoule per kilogram. Plugging in the value into the formula as shown on the slide, after the calculation, you can see that the heat supply is actually equals to 386.025 kilojoule. So therefore, considering the latent heat of vaporization, the heat supply is approximately 386.025 kilojoule. Next is the calculation for the work done. The initial weight of water is equal to 150 gram, and the final weight of the water after 5 minutes boil is equal to 115 gram. Specific heat capacity of water equals to 4.18 kilojoule per kilogram degree Celsius, and the change in temperature is 75 degrees Celsius. And the mass of evaporated water can be found by the difference between the initial weight of water minus the final weight of the water, which in this case is equals to 35 gram or equals to 0.035 kilogram. To find the work done, the formula used is mass of water evaporated times latent heat of vaporization. So 0.035 kilogram times with 2260 kilojoule per kilogram will equals to 79.1 kilojoule. Therefore, the work done by the heat engine is approximately 79.1 kilojoule. Moving on to the last part of the calculation is to find the efficiency of the system. Efficiency is equals to work done divided by heat supply times 100. So the work done is equals to 79.1 kilojoule approximately, and the heat supplied is equal to 386.025 kilojoule approximately, and the efficiency is equals to 79.1 kilojoule divided by 386.025 kilojoule times 100, and the final value will be 20.48%. Therefore, the efficiency of the heat engine is approximately to be 20.48%. That's all from me.
My name is Richie Engelbert, and I will be talking about the difficulties in the project. So one of the difficulties that I'm going to talk is the design and engineering challenges, which is selecting the suitable materials for the steam heat engine. So the solution is that we conduct through research and analysis to identify suitable materials for the steam heat engine, considering factors such as heat resistance, durability, and cost effectiveness. We also utilize computer-aided design with CAD software to optimize component size and configuration, also considering performance, efficiency, and manufacturability. The next problem that I'm going to talk is installation and construction challenges, which is executing intricate mechanical tasks during installation. So the solution is that and also which ensuring proper alignment and connection of the component. So the solution is that we develop a detailed installation plan with step-by-step procedure to guide the execution of intricate mechanical tasks. The next problem that I'm going to talk is that the commissioning and startup challenges, which is the testing and verifying system functionality and performance. So we developed a comprehensive commissioning plan with systematic testing procedure to verify the functionality and performance of the steam heat engine system. And also the next sub the addressing operational concern during startup. So the solution is that we address operational concern through rigorous testing and troubleshooting, seeing expert, and also seeing expert assistant if we need it. The next problem or difficulty is safety and compliance challenges, which conduct through risk assessment at each project phase. So the solution is that we implement appropriate safety measures to mitigate identified risk. We move on to the discussion and testimony or support on the innovation. So for the discussion is that this project is about making a basic heat engine using stuff we have at home. It turns heat energy into mechanical work following the second law of thermodynamics. We use a steel straw to heat water in the web tin. A straw shoots out water vapor when you blow into it. Water vapor is forcefully expelled and make a plastic fan blade spin. It will doing work. Using a butane torch to boil water makes steam. The main data points are the starting volume and mass, boiling time, temperature change, and water weight. So you can calculate heat engine output, work output, and efficiency using numerical values. Heat input depends on water's specific heat capacity, temperature increase, and latent heat of vaporization. To find the work done, you multiply the steam force on the fan blade by its distance. When we calculate predicted heat loss, we take into account heat dissipation to the atmosphere and losses from plastic fan blades. These guesses and calculation figure out how much heat is lost. Heat engine efficiency is measured by heat input, work output, and total efficiency. The study found that you can make a small steam engine using regular parts and actually use it. The heat engine's designs follow the second law of thermodynamics. It's like, the way engine is made is based on this law. Efficiency calculation show how well a heat engine performs. This project demonstrates how we can use thermodynamic concept to design and build a heat engine using parts that are easy to find. Using a small heat engine is a cool way to learn about heat transfer, energy conversion, and efficiency. Talking about the testimony, the experimental results include heat engine prototype testing and operation data. The steam heat engine turns thermal energy into mechanical work. Heat engine can be demonstrated visually. Live or recorded demonstrations are possible. They demonstrate how steam formed by heating water in the web tin pushes the fan blade and generates mechanical effort. Visual can help your project succeed. Our steam heat engine will be compared to various systems and engines. To bolster the case, highlight the project's outperformance and unique advantages. That's all from me. Thank you.
Next, I'll be talking about the future recommendations for our project. Firstly, insulate the boiler better to reduce heat loss and boost efficiency. To increase initial velocity, add a larger fan. A larger fan will increase the area and propelling force. Then conduct continuous testing and analysis. Test and analyze the prototype to improve its functionality and the performance. Fine-tune component size and configurations. Continuously evaluate and adjust the component sizes and configuration to improve integration, compatibility, and system efficiency. Explore other materials to improve durability, dependability, and the performance. Investigate alternative materials for various components. Optimize control mechanisms. Regularly calibrate and fine-tune the control mechanisms to enhance the operational efficiency and steam heat engine control. Safety issues. To reduce high temperature, high pressure, and energy due through safety evaluations and take appropriate safety measures source threats.
Assalamualaikum and hi, my name is Syahmi. Today I will present about our mini project, which is heat steam engine, and my part are significant outcome to mechanical program and the conclusion. Students could imitate the final year project in this mini project. Theory and prototyping were required. The prototype demonstrate their work beyond the theories. The mini project required engineering thermodynamic scenario, so the student must work in teams to apply thermodynamics to a problem or a scenario. Understanding engineering and thermodynamics fundamental is the outcome for this course. Building the project prototype is difficult, so the student must grasp and explain the second law of thermodynamics. Students should investigate further while developing the prototype, since the mini project follows the second law of thermodynamics. This research improves the prototype before the class. Mini project demand teamwork. The team must collaborate to construct the prototype. Mechanical program engineering program outcome requires team communication to make this mini project success. To make this project success requires the teamwork and the soft skill. Students create a prototype in this assignment. The mini project aims to develop a second law of thermodynamics based system. Students must apply the concept in actual life, so the students' mini project concept and improvement were evaluated. It also assessed if the research demonstrates the second law of thermodynamics, its fundamental objective. The mini project aids course and program completion. The work emphasizes thermodynamic. Mini project success requires understanding. Understand and explain thermodynamics can improve the prototype. Using a prototype design is crucial. So finally, the curriculum improves the students' soft skill, particularly in communication and peer sharing. The team collaborate and share knowledge to complete this mini project is very significant. I will continue for a part conclusion. The steam engine mini project goal was to use household items to make a scaled down model. Heat to mechanical energy conversion was shown using the second law of thermodynamics. The initiative evaluated the system efficiency. The team created a steam engine prototype by using the vape tin, steel straw, and plastic fan blades. Water was steamed using the heat. Steam from a steel straw rotate the fan blade. So from this, we can calculate the heat, work, and the system efficiency. The project converted heat energy into mechanical energy using the second law of thermodynamics. Water temperatures and latent heat of vaporization provided heat. So, work was calculated by multiplying steam force of the fan by the distance. Trials and meticulous analysis determined the system engine prototype efficiency by dividing the work done and the heat supply. Context efficiency was 20.48%. This review revealed system performance and improvement of opportunities. Steam engine prototypes taught us material selection, system integration, and efficiency calculation. Heat dissipations, environment impact, and efficiency difficulty were highlighted by the project. The short project increased the team's thermodynamic and heat engine understanding and critical thinking, problem solving, and cooperation skills. The experience paved the way for steam engine technology to break breakthroughs. That's all from me. Thank you for listening to my presentation. I hope you enjoy it. Thank you.